So we're being asked to show that secant is an even function. So remember that an even function, for even functions, it's the same value for the positive and negative inputs. In other words, f of x is equal to f of negative x. It's the same y value for whether it's a positive or a negative. It has symmetry across the y-axis. So we need to show that secant of theta is equal to secant of negative theta. Well, remember, cosine of theta is even. Okay, so that's the starter. Also, secant of theta is equal to 1 over cosine of theta. So because secant is equal to that, if I were to say secant of, let me put it in parentheses. What am I doing? All right, there we go. So then secant of negative theta would be equal to 1 over cosine of negative theta, right? Which is equal to, because cosine is even, 1 over cosine of theta. That's equal to secant of positive theta. Now, another way to do that is you could just plug it into the calculator, but basically that's it. Okay. Now, we could do that by plugging it into Desmos. And remember, it's symmetrical about the y-axis. So if I go to Desmos, and I'm going to switch this out, actually, let's go to the graphing calculator. And if I just say 1 over cosine of x is how we have to graph it. If I look at that, it's symmetrical about the y-axis. So let's just put in like y equals 2. And so if I plug in this point here at pi over 3, it equals 2, and at negative pi over 3, it equals 2. Same thing here, same thing here. So because it's symmetrical, in other words, if you were to divide this in half, it's symmetrical about the y-axis. So the left-hand side of the y-axis mirrors the right-hand side. So if I go the same distance in the negative x direction that I go in the positive, I'll get the same y value. So let's just kind of take a screenshot of that too.